Imagine opening your energy bill and seeing a zero, not a credit, not a mistake, a zero every single month, every single year, and realizing this is not some impossible dream but an everyday reality for certain families who have quietly mastered a system so simple and so effective that it has been hiding in plain sight for centuries. Picture a home that heats itself in winter, cools itself in summer, and runs without sending a single dollar to any utility company, a system not built on modern solar panels or expensive technology, but on principles that are over 400 years old, refined through observation, patience, and an understanding of how nature actually works. Now consider this. The average household spends $400 every year on energy, which turns into $24,000 over a decade, and a staggering $120,000 over 50 years. Money that disappears from your pocket and flows into systems designed to keep you dependent, and yet the alternative has existed all along, waiting for anyone willing to understand it. It begins not with tools or materials, but with the land itself, where the position of the sun becomes the blueprint for everything that follows. Before construction even starts, careful attention is given to how sunlight moves across the property, ensuring that the longest wall of the house faces within 10 degrees of true south. This single decision transforms the entire structure into a passive solar machine, capturing sunlight during the winter when the sun is low, and allowing shade during the summer when it is high, creating a natural balance where the house warms itself when it is cold and protects itself when it is hot, all without consuming energy. This orientation alone can reduce heating needs by 30 to 40%, a massive difference created simply by positioning rather than spending. Then comes the design of the windows, which are anything but random. On the south-facing side, large, deeply set windows line the wall, acting as collectors that pull sunlight and heat directly into the living space throughout the day. These windows are built with thick sills, often 12 to 16 in wide, forming a buffer that slows heat loss and prevents cold air from seeping inside. On the north side, windows are minimal, sometimes just one small opening per room placed high near the ceiling, reducing heat loss where sunlight offers no benefit. The east and west sides are carefully balanced, allowing controlled light without overheating. This arrangement turns the house into a precise thermal system where every opening has a purpose and nothing is wasted. But winter comfort is only half the story, because when temperatures climb to 94 degrees, the system shifts seamlessly into cooling mode through a natural process known as the stack effect. Cool air, being heavier, settles low and enters through shaded openings on the north side, while warm air rises and escapes through higher openings on the south and upper parts of the house. This continuous flow creates a natural ventilation cycle, where fresh, cooler air is constantly pulled inside without fans, electricity, or mechanical systems. The house breathes on its own, maintaining temperatures that can stay 8 to 12 degrees cooler than the outside environment, proving that comfort does not require complexity. At the core of this system lies something even more powerful: thermal mass. Heat is not just something that floats in the air. It can be stored inside solid materials like stone, brick, or earth. Thick walls made from these materials absorb heat slowly during the day and release it gradually at night, acting like a battery that stores warmth and distributes it evenly over time. Unlike modern walls that rely on insulation alone and lose effectiveness as soon as temperatures drop, these massive structures continue to radiate heat long after the sun sets, maintaining a steady indoor climate without constant energy input. This stored heat is then amplified by a heating system that operates in a completely different way from anything commonly used today. Instead of burning fuel slowly over long periods, a masonry heater burns intensely for 1 to 2 hours using just a few pieces of wood, generating extremely high temperatures that allow the fire to burn almost completely. The heat produced is absorbed into a massive structure weighing 3,000 to 5,000 lbs, which then releases that heat slowly over the next 18 to 24 hours. The result is consistent warmth with minimal fuel, where just 2 logs can provide an entire day of heat. Over winter, only 3 to 4 cords of wood are needed, often sourced directly from the land, reducing heating costs to zero. And just when it seems like the system could not become more efficient, there's one final technique that ties everything together in a way rarely discussed. Beneath the floor, hidden from view, lies a network of channels buried 6 to 8 in below the surface, each about 4 to 6 in diameter. These channels connect to an inlet on the south-facing side of the house, allowing cold exterior air to enter and travel underground. As the air moves through these passages, it is naturally warmed by the earth, which maintains a stable temperature of around 5 degrees year-round. By the time this air reaches the interior, it has already been heated by 8 to 12 degrees, reducing the need for additional heating and working in harmony with the rest of the system. When all these elements are combined, orientation, window placement, natural ventilation, thermal mass, efficient heating, and ground tempering, The result is a home capable of maintaining indoor temperatures of 60 to 65 degrees through winter with almost no external energy cost. No monthly bills, no reliance on unstable grids, no vulnerability to rising prices, just a system that works because it follows the laws of nature instead of fighting against them. And yet, despite its simplicity and effectiveness, this approach remains largely unknown, overshadowed by modern solutions that are more expensive, more complex, and far less efficient. It raises a question that is difficult to ignore. If a system like this has existed for centuries and can eliminate the need for $2,400 in yearly energy costs, why is it not the standard? The answer may lie not in its limitations, but in the fact that widespread adoption would fundamentally change how energy is consumed and who profits from it. For anyone who has ever looked at a bill and felt the weight of paying just to stay warm or cool, this knowledge changes everything. It reveals that there has always been another way, a path built not on innovation alone, but on rediscovering what was already known. And once you see how all the pieces fit together, it becomes impossible to unsee the potential of a home that does not just shelter you, but sustains itself.